Good morning. I am Anushka Mukherjee, 21 BAI 1073, and I will be talking about the application of finite automata in game theory. So let us begin with what is game theory? Game theory is basically a branch of mathematics that is concerned with creating strategies for dealing with competitive situations where the outcome of a participant's choice of action depends critically upon the action of other participants. Any problem with interacting participants can be treated as a game, and all the participants' inputs can be analyzed to provide an outcome. This game theory can be done through two algorithms, the min-max algorithm as well as the alpha beta pruning algorithm. But these algorithms follow one basic logic, that is that your move is not only deciding the final outcome but also your opponent's moves, and you try to maximize your chances of winning, whereas your opposition tries to minimize your chances of winning, thereby maximizing their chances of winning. So, now we will talk about certain entities which are correlated with the game theory. So, there are certain terms that we must understand in order to solve the problem by using of principles of game theories like players. So, players, where one side of the game tries to maximize the game, whereas the other side tries to minimize the opponent's score. However, these players can be humans, computer application, or any other entity. For example, take the game of chess. You play chess with the computer. So the computer becomes your opponent, and thereby you are one player and your computer is another player. Then there is something called the environment. This includes both the board and the possible moves of the player. In our case, it is the entire chessboard that is displayed on your device. Successor function. The successor function includes actions and returns a list of moves, comma state pairs, where each pair indicates a legal move and the resulting state. So here every move has already been defined, which the player once puts forward, and the computer, according to the list of moves for that particular move's response, also puts a move. Then you have something called a terminal test. The terminal test specifies when the game is over and the terminal state has reached. In our case, in our example, it is the case of checkmate. Here, the terminal condition has ended, and the final result, whether you have won, the opponent have won, or there has been a draw. Utility function. The utility function is the numeric value for the terminal states. These terminal states have numerical values. Example, 1 is indicating that the user has won, 0 indicating that the user has lost. Now we are going to define automata. Automata theory. So, this field refers to how machines work to a given problem. This can further be expanded into finite automata and non-finite automata. We may now come across finite automata. Suppose there is a tape that is stretched from left to right. This tape is broken into uniform cells that signify a finite number of possible states. The finite state automata shall read the given input in the string from left to right, and after that it will accept the input if there is no discrepancy according to the parameters initialized when the automata was generated. Here, the values of the conditions are finite, and thus it is called finite automata. Some examples of finite automata are refrigerators, elevators, train tracks, computer networks, etc. Now you have the Mealy and the Murray machine. So the Murray machine, the output depends only on one state. Murray machine is efficient in simplifying a given behavior. However, when the output depends on the specific input and the state, so then it is a Mealy machine, and it is efficient in reducing the number of states. Now, a Turing machine. A Turing machine is an abstract computing device which consists of a finite control unbounded memory. Here, the tape is infinite and is extended on both sides infinitely with the help of blank spaces. The program is a list of instructions that guide the machine to take actions based on the current state of its finite control and the bits in its current window on the information on the tape. A step normally involves both a change of state in the finite control or the rewrite of bits in the window. Moving on, this Turing machine is an extended version of the PDA push-down automata. Similar to the transition function in push-down automata, Turing machine has a central component which can be in one of the infinite number of tapes, and the infinite tape is used for storage. So some distinct characteristics of this Turing machine that makes us different from the push-down automata. This Turing machine's tape is infinite on both the ends. They receive input written on tape, which is used as storage, and it also controls the head positions to which the reading or writing is performed. Now we have something called an adaptive automata. So it is basically a typical learning automata system, which is a self-operating machine and responds to a sequence of actions to achieve a specific goal. In the example we had taken before of chess, the sequence of actions, the sequence of movements of all the pawns that will result to either the computer winning or the user winning to reach the specific goal, that is of checkmate. The automata, in turn, may respond based on predetermined rules or adapt to its environmental dynamics. Adaptive automata are internally based on structured push-down automata. Structured push-down automata is pretty much the same as the classical push-down automata. So now we're coming to our main heading, application of automata in game theory. So, application of finite automata in game theory. There's a Neyman's model that states that the players are bounded by computation. The prisoner's dilemma is modeled as an automata. So, later Rubinstein expanded the idea by stating that the costly computation may affect an agent's utility. Then several experiments had been conducted, and the result was shown that finite automata has significantly improved the performance of n players' prisoner's dilemma. This created the need to use adaptive automata, which have the computational power of Turing machine and are highly efficient. The accepting procedure performed by an adaptive automata is done efficiently due to their structure, which is based on the finite state or structured push-down automata. Adaptive automata can handle context dependencies in a strict syntactical way without the aid of auxiliary semantic procedure. It is also used to implement transducers that allow the generation of parse trees as a side effect of parsing sentences. These are also much cheaper way of implementing compared to any other mechanism and can also be considered as an alternative to existing solution of natural programming processing. Adaptive automata has computational power which is very much equivalent to a Turing machine. Thus, strategies presented by adaptive automata may show more complex behaviors than ones described by a finite automata. For instance, learning machines can be constructed using adaptive automata to represent adaptive learning mechanism based on specific input parameters. However, finite automata are a particular case of adaptive automata. If the automata has no rules associating adaptive functions, the model can be reduced to a finite automata. So this is considered important to use adaptive automata naturally where finite automata are required. So here we come to our conclusion. Presenting player strategies in game theory is one of the factors that affects the player's performance significantly. Finite automata are majorly used for simple problems, whereas adaptive automata and cellular automata favor the complex approach where the machine has to be adapted for optimal use. Automatas help the user by identifying the number of elements in the problem and creating an optimal machine that can provide the user with output efficiently and accurately while highlighting all possibilities and coming out with the most optimal solution. I hereby come to the end of the presentation. Thank you for your time. I hope you have understood the importance of finite automata in game